gravitational forces. So, three things. The first one is solar radiation, then as air drag, and thermal effect. What is solar radiation? When you are in the satellite space, any small thing that affects the satellite can influence its movements. Consider that we have the Earth here and the sun here, shining all the time on the way to the sun, to the Earth. And we have, for example, a GNSS satellite. It's moving around the orbit here. As you see, this satellite is moving. Now it's here. The sun can shine directly on the satellite. And even this light can influence the satellite movement. Then the satellite will start going to slightly go to shadow. Here, here is shadow. Let me write it. Shadow. Behind the Earth. And here, no light. And when it comes out from the shadow, again the light can influence. So you see that it's not simple to calculate this, because it is, of course, we compute this, but it's not that simple, because some satellites, they go to the shadow of the Earth all the time. Every time that they rotate it, the sun is moving. The sun is not moving, actually. We are moving. The Earth is moving. The satellite is moving, and the shadow gets is in different direction. The shadow depends on the position of the satellite, the sun and the moon, and it can influence the satellite acceleration. There are some satellites which are geosynchronized. They are all the time affected by sun. So these are also, and this is pretty clear that those satellites which are far from the Earth are more influenced by the solar radiation. But what can we do with that? There is a formula for computing the solar radiation. Solar radiation, if the acceleration from sun, the solar, is minus p v or nu r m c r and u. Use a vector. So what is this? P is called flux of momentum flux. Flux of the sun. A is the cross section. I will explain what is it. Cross section. It's called eclipse factor. And m is the mass of satellite. CR, reflectivity index. And U is the unit vector pointing to sun. What are these things? Let me draw a figure. Is a constant value. As a further remember, eclipse factor is a value which is between 0 and 1. When the satellite is in shadow, it is 0. When it gets slightly, it's a satellite coming back to the light. This view nu it will be between 0 and 1, and when it is on shadow, if it's not in shadow, it's light part, then it is 1. Then we have the flux. So yeah, we have the solar radiation. Mass of the Earth, mass of the satellite, see, is proportional. Is in the denominator. It means that if the mass is higher, if the satellite is heavier, the radiation, the acceleration, or the change in the satellite position is less. So lighter satellites are more affected by solar radiation. That's area of cross section. What is it? Reflectivity. You know that how much of this light energy is reflected by the satellite. So these two are connected to each other. Let me area and the cross section, the unit vector I need to explain. So if I have the satellite here, like this, for example, GPS, and then I have the sun here, we have a vector which is pointing from sun to. So this unit vector, if we have this vector, and we divide it by the size of the vector, if we get the unit vector. And the area that we were discussing now, the cross section is the area which is perpendicular to this unit vector. That's A. So if we have these parameters, we can simply compute how much the satellite is influenced by the solar radiation. The radiation can influence the satellite. Of course, those satellites which are closer and lighter, they are more influenced by the solar radiation.